Sami, we're given f of x is a quadratic expression with positive integral coefficients such that for every alpha comma beta belonging to real number and beta greater than alpha, and integration of f of x dx in alpha comma beta is greater than 0, and g of t is going to be equal to f double dash of t into f of t, and g of 0 equal to 12. If the number of quadratics are a in ab, then if a and b are nice numbers, find a plus b by 2. So tell me, Sammy, a quadratic
So
expression. Yeah,
like we can consider the quadratic equation to be some ax square plus bx plus c.
of course.
And then we um
F double dash of x
x
is
plus
going to be
2a
4a now. Double dash,
2a double dash will be 2a, right?
sorry, single dash is okay, okay.
2ax
Morning.
plus b.
Double dash becoming 2a, correct. So whether they put f double dash of t or f double dash of x doesn't matter. So g of t as they had mentioned is going to be 2a into at square plus bt plus c, correct?
Yes, sir. And g
They had
of 0
mentioned
is 12, so 2ac is 12.
g of 0 is 2ac becoming 12, so ac becoming 6. They have given integration of f of x between the limits of alpha to beta, where beta is greater than alpha is always greater than 0. Integration between the limits is going to give me area. See why they have
Yes, sir.
given that.
Um,
Will vanish, not a problem. Least constant.
like sir, I have like one doubt here. Since
Yeah,
like generally if we have some f of x and then like if we get f dash x is greater than 0, then we can write f of x is an increasing function. So can we do something related to that with this integration thing? Since for any real numbers alpha and beta where beta is greater than alpha, the integration part is greater than 0.
integral of this function is a resultant, it's greater than 0. But if we are able to talk about f dash of x greater than 0, because pretty sure, like, okay, forget the interval at present. Okay, so if this is the case, and you are claiming that derivative of this function will become greater than 0, what do
Yeah,
you do with this? Yeah, I'm seeing that.
sir, I,
Integration. Hmm,
I have an idea. Sir,
yeah, sir.
this integral f of x dx means simply the area enclosed, right? And they
Correct.
say it's greater than 0, so there cannot be any area below the x-axis,
Why?
which means so because for any alpha to beta, they said it is greater than 0. Because if the function is going to go below x-axis, that is, it has two roots means, then we can find an
Did they
alpha.
mention alpha and beta as roots? No, right? They're just two point values.
Yes, sir. So they said for every alpha beta belonging to real. So if the curve goes down the x-axis, then we can find an alpha and beta where the area enclosed will be completely below x-axis, which means it will be negative.
Wordplay.
or it can touch the x-axis. Right.
Yeah.
Now we can apply discriminant less than equal.
Discriminant is b square minus 4ac being less than or equal to 0. Since we got ac value, this is a good trick. So b square should be less than or equal to 24. And since we know all the coefficients are integers, so b values can be 1, 2, 3, 4.
Yes, sir.
We are saying number of quadratics are a, b. Okay, but this is not the b that we are talking about. Okay, we are talking
Like
about
we can find AC value, so A, since both are in like positive integers, then we can like find the factors of 6, like 1, 6, 2, and 3, 3 and 2, like that. And
that's again there. So b for each of the case, for b being 1, the 4 cases of a and c combinations like
4
that.
into 4, 16 cases are there.
16 cases, 16 quadratics are there. They said a, b is a two-digit number, a and b are natural numbers. So 1 plus 6 by 2, 7 by 2, 3.5 is answer. This statement was a catch because it gives area we all understand.
Yes.
But for any alpha and beta being two numbers, like so it's like allowing that quadratic to move, but always the area is being positive, meaning we are not in a position to allow like the graph to go below the x-axis. That is a catch.
Yes.
Good points are there. Still discuss on D, on D. Tell me if you're done with this.
Yes.